We'll now take a look at conditional and iterative operations. In the average miles per gallon algorithm, we performed a set of operations once and then we were done. We just ran through it one time. There weren't any other options to select from. We couldn't select them on alternative operations. We couldn't do any repetitive operations. We just did the whole thing from start to finish and then we were done. This is what we call a sequential algorithm, where we essentially just start at the beginning, we do one instruction at a time, we get to the end, and then we're done. The thing though is, in most real-world settings, problems aren't like this, or the solutions to these problems are not just from start to finish. They usually involve some form of non-sequential operations, such as branching and repetition. So since most problems do involve branching, as picking different options or repeating different lines of code, that means we need some additional statements if we want to be able to implement these types of operations. If we want to implement conditional and iterative operations. So these are what we call control operations. And what they do is they just simply let us change the sequential flow of control. So instead of just going from start to finish and just execute one line of code at a time, we have options such as repeating a set of lines or picking a set of instructions to skip over to. So it just allows us to change that sequential flow of control. Conditional statements are the question asking operations of our algorithm. So the idea is that whenever we ask a question, the next operation we perform depends on the answer to that question. So if that question is true, like if we ask something saying yes, that is true, then we perform some operation. And if the answer is no or false, then we're going to do some other operation. So the most common format that we would use for these types of operations is what we call the if-then-else statement. So kind of here's the general layout of it. So we would say if some condition, and usually this condition is going to be something that's either true or false. So if this condition is true, then we'll perform the first set of algorithmic operations. And if it's else, or if it's otherwise, whatever it is, if it's false in this case, then we would do the second set. So let me just kind of break down the meaning of this statement. So we would evaluate this condition here, this true-false condition. So if this is true, then we're going to perform these sets of operations, whatever this is. I mean, in this format, it looks like just a single line, but it could very well be multiple lines. But we perform all these operations. And then when we're done, we're going to skip over the rest of this, so we would just continue on with the rest of our algorithm. Now, if this condition up here is false, so if it's not true and it's actually false, then what's going to happen is we're going to skip all this here, and we're going to actually start here. So that's what this else part does for us. So it's saying that if our true-false condition is false, then we would just skip this first set of operations. So this just, it's as if we don't even recognize those set of lines. And we do the second set of operations, and then we continue on with the rest of the algorithm. Here's an example of a conditional statement using our number addition algorithm that we've been using before. So here we say if CI is greater than or equal to 10, so this part right here would be our condition. So this is either true or false. So either CI is greater than or equal to 10, or it's not greater than or equal to 10. So if this part is true, then we're going to execute these lines of the algorithm. So we would say set the value of CI to CI minus 10, and then set the value of carry to 1. Now, if our condition is false, then we're going to skip all that, and we're going to go all the way down over here and just say set the value of carry to 0. The second type of statement we'll take a look at are repetition statements. And the idea with this is that we can repeat a set of instructions in a loop-like structure. And this is a very powerful feature, because this is very useful if we want to repeat computations a large number of times. Like, if you're only doing something maybe 2 times, that's pretty simple to do. I mean, you would just go ahead and maybe write out the steps and do it twice. No problems there. But what if you had to do something like 1,000 times? I don't think anyone's going to write 1,000 lines in an algorithm. Instead, we can just use a couple lines and say, we'll just repeat back. And there are different types of loops, but the one we'll talk about for now is what's called the while loop. So the idea with this is we still have our condition, And just like with our if then else statement, that this is going to be either true or false. So if this condition is true, then we're going to perform a set of operations that's going to be part of our loop. So as long as our condition is true, we're going to execute the lines in our loop. We'll do whatever the instructions say. And then we're going to go back to wherever our condition was, and then we check the condition again. And if the condition is still true, then we're going to do those same lines in the algorithm, and we just keep repeating this loop. And just keep going back to the condition, checking it if it's true, and keep doing those lines of code. Now, the idea with the loop is that eventually that this condition has to become false. So we'll keep repeating these lines of code until that condition becomes false. And when that happens, then we'll move on to the instruction after this while loop. So we'll repeat some lines of our algorithm, we'll go back to the condition, and as soon as it's false, we skip over that entire loop and just go on to the next step after that. Here's an example of a while loop. So our first line is just initializing a variable which we call count, and we're going to set it to 1. The second step is our condition. So this part right here is checking that is count less than or equal to 100. So if this is true, we're going to do steps 3, 4, and 5. And we're going to keep doing these 3 lines in the algorithm until count is no longer less than or equal to 100. So let's see what's going on inside this loop. So we're going to have another variable called square in step 3 and set it to count times count. So we're basically getting the square of count is what we're doing here. Step 4 is that we're going to print the values of count and square. And then step 5, we're adding 1 to count. This line is very important, because we talked before about the idea of an infinite loop, where we'll just keep running this loop of lines forever. The only way that would happen is if our condition in step 2 never becomes false. So step 5 allows us to make sure that at some point the condition does become false, because after each time we go through this while loop, we're adding 1 to count. So the first time we go through this, count is 1. The next time count is 2. The next time count is 3. And we're going to keep doing this up until count becomes 101. And when that happens, that means our condition at step 2 is false. So that means we skip steps 3, 4, and 5, and we move on to whatever step 6 is. Now, it's actually quite common in algorithms to not include the line numbers. So, I mean, we've been using line numbers in our algorithms, but that's not always going to be the case. And we just simply execute the lines of the algorithm from top to bottom. So what happens here? Because in our examples with while loops, we would just say, well, we execute steps like 3, 4, 5, or however many lines. So how do we know when to stop a loop? Well, what we can do is use what's called an end of loop construct. And this really isn't a line that we would run, but it's a step in the algorithm that would just tell us when a loop ends. And we would use that instead of using line numbers to indicate when we would stop our loop. Or we would say, well, when we get to this point, we go back into our while loop to check our condition. Or whenever our condition is false, this lets us know what the next step outside of the loop is. So here is an example of such a while loop where we don't have any of the numbers associated with each step, but instead we have our while loop, but then we have this end of the loop at the bottom. So the idea with this is our while loop says we have some true false condition here. So as long as it's true, we're going to do all these operations inside here. It doesn't tell us what steps we actually do. It just, we have this word do here that takes care of that for us. So while this is true, do all these steps that are in this area. And then whenever we get to the end of the loop, we go back to our while loop. And then whenever this is false, well, we're just going to skip past the end of the loop statement, and then we'll just continue following the instructions of the algorithm from that point. We'll now take a look at a different type of while loop. So the while loop we have been talking about so far tests our condition at the very beginning of the loop. So before we even take a look at any of the lines associated with the loop, we have to check to make sure that our condition is true. Another type of loop we can have is called a do while loop. And the difference here is that we test our condition at the end of the loop instead of the beginning. And what this means is that we're going to perform all the instructions inside the body of the loop at least once. So we're going to go through all the lines in the loop, and then we check our condition. If it's true, then we'll go back and do those lines in the loop again. If it's false, then we'll just get out of the loop. So the big difference here is with a while loop, if the condition is initially false, we're not going to run any of the lines that are inside the body of the loop. Whereas with the do while loop, we are guaranteed to run the lines inside the body of the loop at least once. So here is the syntax of a do while loop. So notice at the very beginning, instead of saying while some condition, we just have the word do. That's it. So we're just saying we're going to start running these lines. So we're just going to do all the steps that are inside the body of this loop, all whatever we have down here, and then our condition is at the bottom of our while loop. So then we're going to check our condition, and if it's true, then we're going to come back and do all the operations inside the body of the loop again. If the while loop is false, then we're just going to continue on with the rest of the algorithm. But the whole point here is that these operations here are going to run at least once. So all the operations that we've talked about in this lecture are what we call primitive operations for our computer. And the idea with it is that these are instructions that we can assume our computer knows what to do. If we say, computes, evaluate some expression, store it in a variable, it understands that. We can assume that the computer understands looping. We can assume that the computer understands what it means for an if and a condition, that something's true or false. It understands else. It understands while and do and all that. So the computer can understand these types of instructions without any further specificity, without any further details. Because as we said before, we need to make sure that our algorithms are strictly primitive operations, primitive instructions, and these are primitive operations. So we don't need to go into further details explaining what these operations mean. And what we're going to see in the next lecture is we'll look at some different types of algorithms and see how we can use these operations to design algorithms for solving some very interesting and important problems.